to discuss about complex numbers. What is the complex numbers and addition of the complex numbers, differences of the complex number, conjugate complex number, like this we have to know here now in the class. Before going to the topic, some basic concepts of the complex numbers we must know. All of you know the real numbers. The real numbers are 1, -1, 0, 2, 3 and so on. In the real numbers also, the imaginary numbers also there. What are the real imaginary numbers here? -i, 2i, 3i, like this. These are all the imaginary numbers. How to find the imaginary numbers? Imaginary numbers we have to multiply with I. Here the square root of -1 can be denoted by I. Squaring on both sides, here I square is equal to -1. Suppose we have to go to the one quadratic equation, find the roots of the equation is in this one. X square plus 1 is equal to 0. Here x square is equal to -1. In this equation x has no real roots. How you know this? This equation has no real roots. The discriminant of the quadratic equation is less than 0. The discriminant of the quadratic equation is less than 0. That is b square minus 4ac is less than 0. Then the equation has no real roots. Suppose we take the equation x square plus 1 is equal to 0. Here no value of x here. That is b is equal to 0. A is equal to 1 and c is equal to 1. We have to put in the discriminant here. We have to put in the discriminant 0 minus 4 into 1 into 1. Here -4. -4 is less than 0. The discriminant is less than 0. Suppose it is a discriminant is less than 0 is a complex number. Complex numbers also the one of the part of a real number. What is the complex number? The combination of real parts and imaginary part is called as an complex number. Before we are going to the definition of the complex number in mathematical way, in a complex number is an ordered pair of real numbers a comma b. An ordered pair of real numbers a comma b is, suppose 3 comma 4 is there. This can be also a complex number. The set of all complex numbers is denoted by C. C is equal to the ordered pair of a comma b such that a comma b belongs to R. It can be rotated by R real numbers to real numbers, is mapping from real number to real number. Suppose 3 comma 4. 3 comma 4 is also a complex number. This can be denoted by Z. Z is equal to 3 comma 4. It can be written as 3 plus 4i. Here 3 is an real part and it is an imaginary part. Then we are going to the next topic, that is real and imaginary part of a complex number. Z is equal to a comma b. Here a is called real part and b is called imaginary part of Z. Here suppose 3 comma 4 is there. This is a complex number. It can be denoted by Z. Here 3 is an real part and 4 is an imaginary part. The real part can be denoted by RE of Z and imaginary part can be denoted by IMG of Z. Suppose we have to take a complex number 2 plus 5i. What is the real part here? RE of Z is equal to is 2 and IMG of Z is equal to 5. Here 2 is a real part and 5 is an imaginary part. Next we are going to the next topic is, all of you know I square is equal to -1. I square is equal to -1 is an imaginary number. Then real part of Z is equal to 0. Suppose we have to, in the equation we know that the real part is 0 and the imaginary part is not equal to 0. That number is in purely imaginary. For example, 0 plus 3i. The real part of this complex number is 0 and the imaginary part of complex number is 3i. It is not equal to 0. So, and real part is not equal to 0 and the imaginary part is equal to 0 is called as purely real. Imaginary part is suppose 3i. in this complex number no real part. This is not equal to 0. The real part is not equal to 0 means purely real. Suppose we have to identify like this: imaginary part is equal to 0 is purely imaginary, real part is 0 means purely real. Okay, and then we are going to equality of complex numbers. Two complex numbers z1 and z2 are said to be equal. The first components of z1 and z2 is equal, and second component of the z1 and z2 is also equal. Suppose z1 is equal to a comma b and z2 is equal to c comma d. The first components of z1 is a and first component of z2 is c. A is equal to c and b is equal to d. Suppose we take one example: z1 is equal to x plus iy and z2 is equal to minus 1 plus 2i. Here we have to take the equality of the complex numbers is the first components are equal, that is x is equal to minus 1 and y is equal to 2. And then next topic is addition of a complex number. We have to add a complex numbers also, that is z. Suppose we have to take z1 is equal to a comma b and z2 is equal to c comma d. Then we define the sum of z1 and z2 is equal to a comma b plus c comma d. Then a comma b can be written as is in the complex number form a plus ib, and c comma d can be written as c plus id. We have to come like this: the real parts, sum of the real parts plus I into sum of an imaginary part. That's why you have to write it is a plus c plus I into b plus d. This can be written as the ordered pair of a plus c comma b plus d. This is also a complex number. For example, we have to take a complex addition of a complex numbers means z1 is equal to 2 comma 3 and z2 is equal to minus 6 comma 5. The addition of a complex numbers means we have to add the first components of z1 and then second components of the z1 and z2. What is the first components here? 2 minus 6, and the second components is 3 plus 5, that is minus 4 comma 8. This can be written is in the complex form 4 minus 4 plus 8i. Next we are going to the next topic: negative of a complex number. What is a negative of a complex number? The negative of a complex number of z is minus z. It can be denoted by minus z is equal to minus a comma minus b. Minus z is equal to minus a minus ib. Here for example we have to take it as 2 plus 3i. The negative of 2 plus 3i is minus 2 minus 3i. Suppose in the complex number roots are there. Suppose root 2 plus 5 root 5i. The negative of a complex also the same, minus root 2 minus root 5i. Okay, and then we are going to the next topic, that is difference of the complex numbers. We have to subtract the complex numbers also. z1 is equal to a comma b and z2 is equal to c comma d. Then we define the difference of the complex numbers z1 and z2 is taken as, first we have to write any of the complex number is in the form of negative of a complex number. Suppose we have to take the negative of z2. What is the negative of z2 here? Minus c comma minus d. This can be written as in the complex ordered form minus c minus id. That is, we have to come a minus c is a real number is one part and I into imaginary part is b minus d. This can be written as a minus c comma b minus d. Suppose we have to take one example on this topic. z1 is equal to 2 plus 3i and z2 is equal to 7 plus 4i. The difference of z1 and z2 is 2 plus 3i minus of 7 plus 4i. We have to subtract the first values, a 2 minus 7 plus I is common here, The second component is 3 minus 4 minus 5 plus I into minus 1. It can be written is in the ordered pair minus 5 comma minus 1. Here minus 5 is an real part and minus 1 is an imaginary part. We have to take the next topic like this: multiplication of a complex number. We have to multiply the two complex numbers, that is z1 z2 are the two complex numbers. z1 is equal to a comma b and z2 is equal to c comma d. We have to multiply these two, one a plus ib into c plus id, ac plus aid, ib plus ibc plus I square into bd. Here we have to write the value of I square is equal to minus 1. Put the value of I square is equal to minus 1, that is we have to come closer to the real values. What is the real values here? AC minus BD and I into AD plus BC. It can be, this is in the form of A plus IB. This can be written is in the ordered pair AC minus BD comma AD plus BC. Suppose we take some example. Z1 is equal to 1 comma 2 and Z2 is equal to 3 comma minus 4. Z1 into Z2. AC. What is Z1? A is equal to 1. B is equal to 2. C is equal to 3 and D is equal to minus 4. AC, that is 1 into 3. 3 minus of minus plus 2 into 4, 8, and then AD 1 into minus 4 plus BC 3 into 2 into minus 4, then we can get it as 11 comma 2. Okay, and then we are going to the next topic, that is conjugate of complex number. What is the definition of the conjugate of a complex number is z bar. It is denoted by z bar. Suppose any complex number z is equal to a plus ib. We define the conjugate of z is a plus of minus b into I. It is denoted by mod z. Suppose z is equal to a plus ib, the conjugate of z is can be written as z bar is equal to a minus ib. We take an example like this: z is equal to 2 plus 3i. The conjugate of z is, in place of plus we have to write here 2 minus 3i. That's all. This is the conjugate of a complex number. Suppose we have to take the value of z is root 2 plus 3i. The conjugate of z is equal to z bar is equal to root 2 minus 3a. Here plus is, here in z a plus is there, then the conjugate is minus. Suppose here minus is there, then the conjugate is plus. Okay, and then we are going to the next topic: division of a complex number. Division of a complex numbers means we have to take two complex numbers, that is z1 and z2. It is not equal to 0. Then we have to define z1 by z2 is equal to a comma b by c comma d. A comma b is in the ordered pair. This can be written as a plus ib. C comma d is in the ordered pair. It can be written as c plus ib. We have to rationalize the denominator here. What is the denominator here? C plus id. We have to rationalize that. In place of plus we put it as minus c minus id by c minus id. Then we have to multiply the numerator and denominators. Denominator ac minus iad plus ibc, minus into plus minus I square bd by, in the denominator part we have the values is c plus id into c minus id. This is in the form of a plus b into a minus b, that is a square minus b square. That's why we have to write it in the denominator part c square minus id whole square. Here we know that I square is equal to minus 1. Put the value of I square here. I square is equal to minus 1. Then we have to come closer to the real numbers and we have to common the I value here. It can be written is also in the ordered pair AC plus BD by c square plus d square comma bc plus ad by c square plus d square. Like this we have to write here. Suppose some note point is there: additive inverse of a plus ib is minus a minus ib. This is the value. This is additive inverse it means difference of a complex number. Negative of a complex number and additive inverse of a complex number is same. We have to put the value in the z. Put the value in the before value of z, a plus ib. A minus of a plus ib is minus a minus ib. Then square root of a complex number. Complex number z, any value of z belongs to C such that z is equal to a plus ib. The formula of the square root of a complex number is a square root of a plus ib plus or minus square root of a square plus b square plus 8 under root by 2 plus I into square root of a square plus b square minus a by 2 by under root. Here the value of b means a plus ib. B is an imaginary part. In imaginary part is greater than 0. In between these two we have to get here plus. Suppose b is less than 0, so we have to put here minus. Okay. In this formula we have to find the square root of a complex number and then modulus of a complex number. What is the modulus of a complex here? A non-negative real number. A non-negative real number square root of a square plus b square. Here a is a real part and b is an imaginary part. Square root of a square plus b square is called as a modulus of z. It can be denoted by mod z. It can be written as some r also. Mod z is equal to root of a square plus b square is equal to r. Some example we have to take the value of z is equal to 2 plus 3i. Then we have to find mod z is equal, that is a is equal to 1 and b is equal to 2. 2 square plus 1 square plus 2 square, that is 4 plus square root of 4 plus 1, that is equal to root 5. This can be written as small r also. Okay, then we are going to some problems like this. We have to difference of the two values z1 and z2. z1 2 comma minus 1, it can be written as 2 minus I. This is the complex number form. z2 is equal to 6 comma 3, it can be written as the complex number form 6 plus 3i. That is, we have to come between 2 plus 2 minus 1 minus of 6 plus 3i. Here it is 1. 2 minus 1 2 minus 1, 2 minus 6 is minus 4, minus I minus 3i minus 4i. This can be written is in the ordered form minus 4 comma minus 4. And also in this way we have to add the two complex numbers also, z1 plus z2. What we get here? 2 plus 6 comma minus 1 plus 3. 2 plus 6 means what we get here? 8. 8 comma minus 1 plus 3 is 2. It can be written is in the form of 8 plus 2i. This is the form of addition to find the addition of complex numbers and difference of the complex numbers also. Then multiplication of z1 and z2. z1 is, we can take it as 3 comma 5 and z2 is equal to 2 comma 6. The value of z1 into z2 is equal to, what is the formula here? A is equal to 3 and b is equal to 5, c is equal to 2 and d is equal to 6. What is the formula here? Already you have, before you are knowing the formula of multiplication of a complex number means AC minus BD plus BD. AC minus BD comma AD plus BC. That's why you have to write here 3 into 2 minus 5 into 6 comma 3 into 6 plus 5 into 2, that is 6 minus 30 comma 18 plus 10 minus 24 comma minus 28. This is in the form of, we have to written in the complex number 24 plus 28i. Here it is, the real part is minus 24 and the imaginary part is 28. Okay, and then we are going to the next one, the additive of a complex, additive inverse of a complex number. Additive inverse is same as the negative of a complex number. These two are equal. Then we have to find the z is equal to root 3 comma I. This can be written is in the complex number form a plus ib, that is root 3 plus 5i. The additive inverse is minus z. Minus z means minus of root 3 plus 5i, that is minus 3 comma minus 5i. This is also the one of the example of negative of a complex number also. Okay, and then we are going to the next one. Write the following complex numbers is in the form of a plus ib. 2 plus 3i into 3 plus 4i. This is in the form of z1, z2, multiplication of the complex numbers z1 and z2. This is also the same value. 2 into 3 plus 2 into 4i minus 3 into 3i plus minus into my plus minus 12i square. The value of I square we have to put here. I square is equal to minus 1, substitute here. Then plus will become minus will becomes plus 6 minus I plus 12. 6 plus 12 is 18i. 18 minus I. The complex number is in the form of a plus ib. Here a is 18 and b is equal to minus 1. Like this we have to write here. And then next one is write the conjugate of a complex number. Already we know the definition of a conjugate of a complex number. Conjugate of a complex number means z is equal to a plus ib. The conjugate of a complex number is a minus ib. Suppose we have to know the here a 3 plus 4i. Here the complex conjugate of a complex number is 3 plus, in place of plus we have to put here minus here. And then next one, the difference of a two complex numbers. Difference means here minus the negative of it, we have to write the first negative of a complex number here. Minus of plus 4, minus 4 minus into minus plus 20i. 15 minus 4, that is equal to 11. 20 plus 3, 23i. The complex conjugate of 11 plus 23i is 11 minus 23i. In place of plus we have to write here minus. This is the complex conjugate of the example of one of the example of complex conjugate. And then we are going to some problems is there. We have to write in the homework. You have to solve this one. First one is 2 minus 3i into 3 plus 4i. This also we have to written is in the form of a plus ib. Then we have to multiply these two complex numbers. These two complex numbers, what we have to write the complex numbers here? 2 into 3, 6 plus 2 into 4i, 8i minus 3 into 3, 3i, 9i plus into minus 4i square. Here also write the value of I square is minus 1, that is equal to we get is at 6 plus 4, 10 minus I. Here a is equal to 10 and b is equal to minus 1. Like this we have to write the second problem also is in the form a plus b whole cube form. We have to write the formula here. Then we can reduce the value is in the form of a plus ib. Like this the third one also the same, but here roots are there. Some roots root 3 plus into 2 root 3, that is 2 minus 2 into 3. Okay, and then minus root 3 into I plus minus 2 root 2 plus into minus I into square root of minus 2. This is also we have to reduce is in the form of a plus ib. Here I power 9. It is also we have to write it as a plus ib. What is I power 9 here? I is an imaginary value. Here the value of b is 1. Then it is also we have to write the real part is 0. What is the real part is 0? Here the real part is 0 means what is purely imaginary or purely real. Real part is equal to 0. Then we have to know that what is the real part is equal to 0 means we have to know the some definition of this. Real part is equal to 0 and the imaginary part is not equal to 0. What is this here? Purely imaginary. But we know that I power 9. What is the value here? I power 9. I power 9 means we have to write it here like this. I square into I square into I square into I square into I. The value of I square is minus 1. Minus 1 into minus 1 into minus 1 into minus 1. Here minus minus plus, plus into minus minus, minus into minus plus, plus I. that is equal to 0 plus I. Here capital A is equal to 0 and B is equal to 1. Okay, and then we are going to next one. Find the square root of a complex number. Already we know the value of the formula of a square root of a complex number. Here A is equal to 7. B is equal to 24. Here what is the value of B here? Positive or negative? Here positive. Therefore it is B greater than 0. That we have to write it is square root of A square plus B square under the square root of A plus 2 by 2 plus I into root of square root of A square plus B square minus A by 2. We have to see this one. We have to put the value of A is equal to 7 and B is equal to 24 in this problem solution. We have to know that square root of under the root of 49 plus 576 plus 7 by 2 plus I into square root of 49 plus 576 minus 7 by 2. Here 49 plus 576 can nothing but 625. What is the root of 625 is 25. Root of 25 plus 7 by 2 plus I into square root of 25 minus 7 by 2. That we can get it plus or minus root 32 by 2 plus I into square root of 18 by 2. That is root 16 plus I root 9. Root 16 is nothing but 4 and root 9 is nothing but 3i. That is square root of 7 plus 24i is equal to plus or minus square root plus 4 plus 3i. Like this we have to find the another formula also, 49 plus 7 root 3. This example also we have to do like this. Here the value of A is equal to 49 and B is equal to 7 root 3. Substitute in the formula like this. We have to find here the value of B is greater than 0. Okay, then we have to find put the equations, the values of A and B here and we have to get the solution like this. Okay, and then we are going to the next one. Next problem like this. Suppose two complex numbers are there. These are conjugate to each other. We have shown that these values are conjugate or not. Z1 is equal to 2 plus 11i by 25 and Z2 is equal to minus 2 plus I by 1 minus 2i whole square. First we have to take it as Z2 is equal to minus 2 plus I by 1 minus 2i whole square. This can be rearranged as a minus b whole square form. A square, what is a minus b whole square here? A square plus b square minus 2ab 1 plus 4i whole square minus 4i. Here I square value is minus 1. We have to substitute here minus 1. 1 minus 4 is minus 3 and minus 4i. Then we get the rationalizing the denominator here 3 plus 4i into 3 plus 4i. What is the rationalizing part here? 3 minus 4i. We have to multiply the value of the numerators and denominators. What is the numerator here? 2 into 3 6 minus into minus plus 8i by minus into minus 3i plus minus 4 into minus I whole square. In the denominator part we have a plus ib into a minus ib. What is the a plus b? A plus b into a minus b. The formula is a square minus b square. Here the value of a is 3 whole square and value of b is 4i whole square. That is 9 plus 16, that is equal to 25. To minus 2 plus 11i by 25 we can get lastly, and then Z1 is equal to 2 plus 11i by 25 and then we can get the value of Z2 is 2 plus 11i by 25. These two are conjugate to each other. Already we know the definition of the conjugate. A plus ib, Z1 is equal to a plus ib. The conjugate of Z1 is equal to a minus ib. Okay, and then for this we have to find that the Z1 and Z2 are conjugate with each other. Then we have to solve some problems. Write the additive inverse of the following of the complex numbers. Additive inverse means we have to find minus z, that is the difference negative of a complex number. First we have to add minus 6 comma 5 and 10 comma 4. First we have to add the first components here, minus 6 plus 10 and 5 plus 4 minus 6 plus 10, what we get here? 4 comma 9. The additive inverse is minus 4 comma minus 9. Okay, and then similarly the second one also the same, 2 comma 1 plus minus 4 comma 6. First we have to add these two complex numbers, 2 minus 4 and 1 plus 4. 2 minus 4 means minus 2 and 6 plus 1 means 7. The additive inverse is minus 2 minus 7. This can be written is in the ordered pair minus 2 comma minus 7. Okay, and then multiplicative inverse of a complex number. Already you know the definition of the multiplication inverse of a complex number, and we have to put the values in that formula. We can get the multiplication inverse of a complex number. And then this is the same also, we have to know that the values, this is in the form of a plus ib form. We have to practice these ones. Next problem is complex number z has an argument theta lies between 0 and pi by 2 and satisfies the equation mod z minus 3i is equal to 3. Then prove that cot of theta minus 6 by z is equal to I. We have to prove that the value of cot of theta minus 6 by z is equal to I. Then already we know the value of z is equal to x plus iy. Then they give an argument of z is equal to theta. Then the value of argument of z is equal to tan inverse y by x. Suppose we have to take a real part and imaginary part like this. We have to take this like this. Here it is theta. Then we can get it is a real part, it is an imaginary part. Then theta is equal to tan inverse of y by x. Tan inverse, we can go to the next one, RHS side, we get y by x is equal to tan theta. Already we know that the given problem in the hypothesis, we have to know that mod z minus 3i is equal to 3. Then replace z in the form of x plus iy. In the place of z, we have to put the value of x plus iy here. X plus iy minus 3i is equal to 3. Then take the common of I here. X plus I into y minus 3 is equal to 3. Squaring on both sides. Here we have to write here mod z. Mod z means we have to, the formula is square root of a square plus b square. Here the value of a is x. That's why we are writing here x square, and the value of b is y minus 3. Instead of y minus 3, b square we have to write here. Instead of b, we have y minus 3 here. Then y minus 3 whole square is equal to 3. Squaring on both sides, we get the root and the square get cancelled here. 3 square is equal to 9. Then we can expand the value of x square plus y minus 3 whole square is equal to 9. It is in the form of a minus b whole square, that is a square plus b square minus 2ab. Here we have to write here x square plus y square minus 6y plus 9 is equal to 9. In LHS and RHS 9 is there. Then we can get cancelled. The value of we have to find the value of 6y is equal to x square plus y square. In the hypothesis, we know that the value of, we have to prove that cot of theta minus 6 by z is equal to I. Okay, and then we have to take the LHS here, cot of 6 minus z. What is the cot theta here? We know that the value of tan theta is y by x. Tan theta is equal to y by x. Then cot theta is equal to what? 1 by tan theta here. Then 1 by y by x. We take it as reverse. Then cot theta is equal to x by y. Here we have to put the value of, in place of cot theta is x by y. Then minus 6 by the value of z is equal to, already you know the value of the complex z is equal to x plus iy. We have to put here x plus iy. X minus y, we have to take some same one side, and minus of 6 by x plus iy. X plus iy is there. In the denominator, we have to take the rationalize the value of denominator. What is the denominator here? X plus iy. we have to rationalize the denominator here, x minus iy by x minus iy. Numerator we have to multiply here, 6 into x minus iy by denominator x plus iy into x minus iy. This is in the form of a plus ib into a minus ib, that is a square plus b square. What is the value of here? A minus b into a plus b is equal to a square plus b square. That's why you are writing here x square plus y square. In place of x square plus y square here, what is the value is there? 6y. We have to put here in the denominator part, x in place of x square plus y square is equal to 6y. 6 get cancelled. What we get here? X by y minus of x minus y by y. Take the LCM of these two ones. The LCM is y. X minus of minus x. Minus into minus iy. X get cancelled here. Then iy by y. Y get cancelled. Then we have to take it as y. Hence what we have to prove here? Cot theta minus 6 by z is equal to I. We take the LHS of cot of theta minus 6 by z. We can get the value of I here. That is equal to RHS. That's why LHS is equal to RHS. Hence this problem is proved. Okay. And then next one is express the value of minus 1 minus I in polar form with principal value of amplitude. Okay, with principal value of amplitude means root r into 1 plus I is equal to r into cos theta plus I sin theta. Here r is equal to square root of real part whole square plus imaginary part whole square. This is the principal value of the amplitude form. Minus 1 minus I is equal to r into cos theta plus I sin theta. We have to equate the real parts and imaginary parts. What are the real parts here? Minus 1 is equal to r cos theta, and imaginary parts is the multiplier of I is here minus 1, and here it is r sin theta. R cos theta is equal to minus 1, r sin theta is equal to minus 1. Then we can get the value of amplitude is in the theta form. Tan theta is equal to r sin theta by r cos theta. R get cancelled. Sin by cos means tan, that is equal to minus 1 by minus 1. We can get it as 1. Then the value of tan theta is equal to 1. Then we have to find the value of r here. What is the value of r here? Square root of a square plus b square. Here the value of a is equal to minus 1 and b is equal to minus 1. Put in this equation, we can get square root of minus 1 whole square plus minus 1 whole square. Minus 1 whole square is equal to 1 and minus 1 whole square is equal to 1. Therefore the value of root 2 is r is root 2. R square is equal to 2. Then r is equal to square, it becomes the right hand side. We can get r is equal to plus or minus root 2. So then we are r is the value of positive and negative. Two values are there, but we take only positive number, that is equal to r is equal to root 2. Then tan theta is equal to 1. Tan theta is equal to 1. Then theta is equal to 3 pi by 4. It satisfies the equation minus root 2 cos theta. In place of theta we can get it as 3 by 4, and in place of theta we can get it as minus 3 by 4. This is the principal value of the amplitude form. And then if the amplitude of z minus 2 by z minus 6i is equal to pi by 2. Find the locus of this equation. Then we have to know the value of z here. Already we know that z is equal to x plus iy. We have to put the here x plus iy minus 2 by x plus iy minus 6i. Then we can come between x minus 2 plus iy. Here we take the common here, x plus I into y minus 6. We have to rationalize the denominator. In place of plus we have to put it as minus. Then we have to multiply the numerator and numerator, denominator and denominator. In the place of numerator, x minus 2 into x minus I into x minus 2 into y minus 6 plus iy into x minus into minus plus minus I into I square, y into y minus 6 by, in the denominator part we have is in the form of a plus b into a minus b, that is equal to a square minus b square. Here the value of a is x whole square and value of b is I into y minus 6 whole square, that is x square minus plus I square into y minus 6 whole square, but it is in the form of minus into minus plus x square plus y minus 6 whole square. The real part will come one side and the imaginary part will become this side. Well, what is the real part here? X into x minus 2 plus y into y minus 6 by x square plus y minus 6 whole square, and the imaginary part is xy minus of x minus 2 into y minus 6 by x square plus y minus 6 whole square. Here we have to take it, this value is a and this value is b. What we have to find here? The value of the locus of the equation, but the amplitude form is a plus ib is given. The value in the hypothesis we have to know that the amplitude is pi by 2, that is a plus ib is equal to pi by 2. We know that the value of pi by 2 is a is equal to 0 and b is greater than 0. Therefore it is equal to 0 and it is greater than 0. If this value of a is equal to 0, then the denominator will get the RHS side. Then we can get totally x into x minus 2 plus y into y minus 6 is equal to 0. Suppose we have to multiply this, x square minus 2x plus y square minus 6y is equal to 0, and the value of this side, the value is greater than 0, this the denominator will get this side. Then we have to multiply and we can get the imaginary part is greater than 0. 3x plus 5 minus 6 is greater than 0. What we have to know that the amplitude is pi by 2. The amplitude is pi by 2. Find the locus of z. Here the value of locus of z. Okay, and then we can go to the next one. Given real roots is equal to 1, then x square plus y square plus x plus y by x square plus y square plus 2y plus 1 is equal to 1. This RHS get this come outside. Then x square and y square get cancelled here. X minus y minus 1 is equal to 0. Therefore the locus of z is x minus y minus 1 is equal to 0. Okay, why? Because we have to take it is 1, then here it is the value is, this value is equal to 0, then we can get here is equal to 1. Pi by 2 means is equal to 1, that's why we are taking the real part is equal to 1. Okay, then the value is this RHS come to this side, then x square and y square get cancelled here. Then the locus of z is x plus x minus y minus 1 is equal to 0. Then we are going to the next problem. Find the least positive integer n satisfying the equation 1 plus I by 1 minus I whole power n is equal to 1. What is the least value of this equation? We have to find the value of n. We have to find here. Given we know that by problem hypothesis we given 1 plus I whole by 1 minus I whole power n is equal to 1. We take it as the rationalize the denominator here. Then the numerator and denominator can be multiplied here. 1 into 1 1 plus I into I square. The value of I square is minus 1. A plus b into a minus b is a square minus b square. 1 minus I whole square, the whole power n. 1 minus I square means minus 1. Then the denominator will becomes 2. 1 get cancelled here. 2i by 2 is equal to n, that is equal to I power n. I power n means we have to take the value of n is equal to 1. It is an I is an imaginary number, but it is not a least positive integer. Suppose n is equal to 2, I square is equal to minus 1. Minus 1 is not a positive integer. Then n is equal to 3. We have to take it as n is equal to 3 here. I cube is also I. This is not a least positive integer. Then we can take the value of n is equal to 4 here. I power 4, that is I square into I square minus 1 into minus 1, minus into minus plus 1 into 1, 1. 1 is the least positive integer. Then the value of n is equal to 1. This equation will satisfy only n is equal to 4. Then it satisfies LHS is equal to RHS. And then next problem is find the real root value of theta in order that 3 plus 2i sin theta by 1 minus 2i sin theta. First one is real number and second one is purely imaginary. Already we know that the what is real number, what is purely imaginary number. First we have given the hypothesis, we have to know that the value of z is equal to 3 plus 2i sin theta by 1 minus 2i sin theta. Rationalize the denominator here, 1 plus 2i sin theta by 1 plus 2i sin theta. We have to multiply both the numerators and denominators. That we have to get 3 into 1 3, 3 into 2i sin theta 6i sin theta, 2i sin theta into 1 2i sin theta plus into plus 4 I sin theta whole square. It is in the form of a minus b in a plus b. A minus b into a plus b is equal to a square minus b square. That is 4i sin theta means I square sin square theta, that is minus 4. The real part is what here? 3 minus 4 sin square theta. A plus b into a minus b will get it as 1 minus 4 into I sin theta whole square, and the imaginary part is 8 sin theta 6. How will you get here? 8 sin theta 6i sin theta plus 2i sin theta is 8i sin theta by 1 minus 4 into I sin theta whole square. This is an real number, this is an imaginary part. This is an real part, this is an imaginary part. Then continuation of this problem is, first one is what here? The real number and purely imaginary. Imaginary part is equal to 0. Then we can get what is the imaginary part here? 8 sin theta by 1 plus 4 sin theta whole square. This is equal to 0. Then the denominator will come right hand side. It becomes 0. 8 sin theta is equal to 0. Then we can get sin theta is equal to 0. Sin theta is 0, then the value of theta is 0 degrees. In the general solutions, already we know the first in the first topic, general solutions of the trigonometry, we know that sin theta is equal to 0, n pi plus minus 1 whole power n into alpha comma n belongs to z. Here alpha value is 0 degrees. We have to put here 0. Then we can get it as theta is equal to n pi. And then second one is what here? Purely imaginary. In purely imaginary means the real part is 0. What is the real part here? 3 minus 4 sin square theta by 1 plus 4 sin square theta is equal to 0. 3 minus 4 sin square theta by 1 plus 4 sin square theta is equal to 0. Then the denominator will come to the right hand side. The total value is 0. Then we can get 3 minus 4 sin square theta is equal to 0. 4 sin square theta is equal to 3. Sin square theta is equal to 3 by 4. Sin theta is equal to root 3 by 2. What is the value of root 3 by 2 here? Theta is equal to pi by 2. Then the general solution of sin theta is equal to sin alpha. Then we can get theta is equal to n pi plus minus 1 whole power n into alpha comma n belongs to z. That's why you are writing here alpha is equal to pi by 3. Okay, and then we can get the value of real number is theta is equal to n pi, and purely imaginary number is theta is equal to n pi plus minus 1 whole power n into pi by 3, and where n belongs to z. And then we are going to the next one, next problem. If x minus iy whole power 1 by 3 is equal to a minus ib, then show that the value of x by a plus y by b is equal to 4 into a square plus b square. In the hypothesis, we have to know that the value is x minus iy whole power 1 by 3 is equal to a minus ib. In the whole power 1 by 3 is there, then we are going to cubing on both sides. What is the value of a minus ib here? A minus b whole cube formula, all of you know that a cube minus 3a square b plus 3ab square plus b cube. That's why we are going to, in place of a is a, but in place of b we have to put the value of ib here. What we get here? A cube minus 3a square. B means here ib plus 3a into b means ib whole square minus ib whole cube. What is this here? What is the comparison of real and imaginary parts on both sides? What is the real part in the left hand side is x. What is the real part of right hand side here? A cube minus 3a square ib minus plus I square means here minus 1 minus 3ab square minus ib cube. What is the real part here? A cube and minus 3b square a. And what is the imaginary part in the left hand side? Y. And the right hand side is 3a square b and b cube. Then we can get the common here is a square minus 3b square. Here we can get the common is in b. Then we can get the common here b, 3a square minus b square. In this multiplication is come to this side, division, x by a is equal to a square minus 3b square, y by b is equal to 3a square minus b square. What we have to know this in this problem, we have to know the formula of a minus b whole cube formula. X by a is equal to a square minus 3b square and y by b is equal to 3a square minus b square. We have to add these two values. A square plus 3a square means 4a square. B square plus 3b square means 4b square. Here 3b square. 4a square minus 4b square. Then we can get common 4 here. A square minus b square. What we get here? X by a plus y by b is equal to 4 into a square minus b square.